Hey, how's it going everybody? In this video, I'm going to go through this Leetcode 167 to sum number 2. This question was asked by Google for the past 2 years. In the past 6 months was asked by Amazon, Apple, Bloomberg, etc. Let's take a look at it. Given an array of, this is a one indexed array, and this is important, of integer of numbers, and they are sorted in the non-decreasing order. And we need to find the two numbers within this array such that they add up to a specific target. And at the end, we need to return the indices of these two numbers. And also, we are guaranteed that there will be exactly one solution. And another constraint that we are under is that the solution must be running under constant space complexity. Let's take a look at an example over here. We are given an example 2, 7, 11, and 15. Within this array, the first number plus the second number, and that is 2 plus 7, that's 9. That is equal to the target. And at the end, we need to return another array of 1 and 2. And that's because the index of the first number is 1. And the index of the second number, that's 2, because we are operating under a one indexed array. So that is the first example. Second example, we are given another array, right? 2, 3, and 4. The target that we're looking at is 6. And the first number plus the last number, and that's the target, right? So the index of the first number is 1, and the index of the last number is 3, and that's why we need to return an array that's containing two numbers, 1 and 3. To solve this problem, we are going to use a two pointers method. The left pointer starts from the beginning and the right pointer starts from the end. And then we will have a loop that allows us to move the left pointer forward or move the right pointer backward, such that at some point the sum of these two numbers will be exactly the same as the target. And concretely, so let's take a look at an example over here, how we can apply it. The left pointer starts from 2, the right pointer starts from 15, 2 plus 15, that's 17, and 17 is greater than the target of 9, and we need to decrease the current summation, right? So the way that we can decrease it is to move the right pointer backward, right? So from 15, we can move it to 11, and then we do the summation again. So gonna be 2 plus 11, that's gonna be 13. 13 is still greater than 9, right? And we would still do the same thing. So we will move the right pointer backward by 1 unit. So and here it's gonna be 2 plus 7, and that's exactly 9. So in the other way around, if the number is too small, right? If the current summation is too small, what we can do is to move the left pointer forward by 1 unit, right? And then we can, ultimately we were able to hit the target at some point. So now let's take a look how we can implement it in Python. We'll have a left pointer and the right pointer. Started from, left pointer starts from the beginning. The right pointer started from the end. While the left pointer is less than the right pointer, actually, this condition does not really matter because we are guaranteed that we will be able to find exactly one solution. But this condition is for a standard two pointers approach. At the current sum, right? So how do we calculate the current sum? So we look at the number at the L index in the left pointer index plus the number at the right index, and that is our current sum. If the current sum is too small, is smaller than the required target, and then we will move forward the left pointer by 1 unit, right? So this is how we can advance the left pointer. And otherwise, if the current sum is too big, is bigger than the required target, and then we can move the right pointer backward by 1 unit at a time, right? So we can move the right pointer from 15 to 11, etc. to 7, etc. And else, meaning that the current sum is exactly equal to the required target, and then we will return the index. And remember, and this is a one indexed array. That's why we need to add 1 to the pointers so that we can have a 1 indexed. So that is the solution to this problem. And for time complexity, it's going to be big O of n because we are using a 2 pointers method. For space complexity, it's going to be big O of 1. We didn't use any other data structure. Thank you so much for watching. I hope this is helpful.